So hello sir, good day. So this is my topic in data structure and algorithm. So my topic is all about quicksort. So from the name itself, quicksort. So it's just a quick sorting of algorithms from the array. So what is a quicksort algorithm? Quicksort is a high efficient sorting algorithm and is based on partitioning of arrays of data into smaller arrays. A large array is partitioned into two arrays, one of which holds a smaller value than the specified value, say pivot, based on which the partition is made, and another array holds value greater than the pivot value. So si quicksort daw po is a partition of data that has a smaller value and the higher value, and also in the middle is the pivot. So quicksort partitions an array and then call itself recursive twice to sort the two resulting subarrays. This algorithm is quite efficient for large size dataset as its average and worst case complexity are O and square respectively. So next one is quicksort application. So quicksort is used everywhere where a stable sort is not needed. Variants of quicksort are used to separate the smallest or largest elements. Quicksorts divides and conquer enable the use of parallelization. Quicksort is a cache-friendly sorting algorithm as it has a good locality of reference when used for arrays. Quicksort is tail recursive and hence all tail call optimization can be done. And last is quicksort in is an in place sort that doesn't not require any extra storage. Next one is these are the steps on how it works. The first one is find a pivot item in the array. This item is the basis for the comparison for a single round. So in finding a pivot, you can choose any of the elements in the array within the one. Maybe it's a median, the first array, or the last array, or maybe a random one. And next one is after we choose a element in our array, we can start the pointer, the left pointer at the first item in the array. So we can put the iterator on our values. And next is start a pointer, the right pointer at the last item. So the step 2 entry is putting an iterator from left pointer to the right pointer. And next is while the value at the left pointer in the array is less than the pivot value, move the left pointer to the right and add 1. Continue until the value at the left pointer is greater than or equal to the pivot value. So it says that if the value at the left pointer is less than the pivot, then move the left pointer to the left and add 1. Then continue until the value of the left pointer is greater than the pivot. Then next one is while the value at the right pointer in the array is greater than the pivot value, move the right pointer to the left, then subtract 1. So continue until the value at the right pointer is less than or equal to the pivot value. So next is if the left pointer is less than or equal to the right pointer, then swap the values at this location in the array. So if sabi dito is kung mas malaki daw po yung left pointer than the right pointer value, then we can swap the arrays from right to left. And next one is move the left pointer to the right by 1 and the right pointer to the left by 1. So mag-adjust po tayo from ng 1 step from the left and 1 step from the right. And next one is if the left pointer and the right pointer don't meet, go on step 1. So if hindi pa rin pa na-meet ng right pointer and left pointer yung value na gusto niya, desired value niya, then babalik ka sa step 1. So, next naman po is step-by-step procedure with the example. So, as we can see here, meron po tayong 6 elements. So, the elements of the arrays are 4, 2, 6, 5, 3, and 9. So, first step is determine the pivot. So, in determining the pivot, pwede po tayong mamili kung kahit saang position po siya naroon. Kung pwede po siya sa median, sa first value, the last value, or maybe a random one. So, ang pinili ko po is a random one, then I choose the pivot value as the 5. So, next step after we determine the pivot value is to start pointer at the left and right. So, ilalagay na po natin yung iterator from left and to the right. So, ang iterator po natin from the left is the value of 4, and the right iterator is the value of 9. So, after we put the iterators, magpro-proceed na po tayo sa step 3. So, since 4 is lesser than 5, then shift left pointer. So, magmo-move po tayo since mas maliit po si 4 kaysa sa 5. Magmo-move po tayo pa left. Then, next naman is since 2 is lesser than 5, magmo-move po ulit tayo from the left pointer. So, mag-shift ulit tayo. So, as we can see, itong step 6 is nasa value of 6 na po yung left pointer natin. Then, since 6 is greater than 5, then pwede na pa tayong mag-stop. So, next naman is step 5 na po tayo. So, sa right pointer naman po tayo. Then, since 9 is greater than 5, then shift right pointer. So, mag-shift po tayo ng right pointer. So, lilipat na po tayo kay 3. And, step 6 is swap value at the pointers. So, since si 6 is, si 3 is lesser than 5 and 6 is greater than 5, then mag-shift pa tayo or swapping ng value position. So, as we can see sa step 6 na po, lumipat na po si 3 from the right and napunta naman na po si 6 from the left. Baliktad po pa. Si 3 from the left and 6 from the right. So, next step is move the pointer one more step. So, from the pointer na nasa left array of 3 and 6 sa right naman is mag-move po ulit tayo ng one more step. So, mapupunta na po tayo sa pivot element natin. So, if nakatapat na po yung mga iterators natin sa pivot element, ang last step naman po is since the 5 is equal to 5, so since the pivot element is equal to itself, so mag-move po tayo ng one more step to the left and right. Then, after pa natin mag-move, as we can see, hindi pa po siya fully na talagang na ayos. So, after pa natin mag-move, pwede po ulit natin siyang i-partition from the element 1 to 3, then 5 to 6. So, ang value po ng element na yan is from 4 to 3. Pwede po ulit natin siyang i-partition para po maging magkasunod-sunod na po sila. So, pwede pag pinartition po ulit natin siya, hindi ko lang po kasi nailagay sa mga example, is magiging, ang value na po niya is magiging pag pinartition po natin tong right element, pwede po, ang magiging pivot po niya is si 2. And since 2 is lesser than 4, lilipat po siya lilipat po si 4 sa kabila. Then since 2 is lesser than 3 ulit, magsaswap ulit sila. So, ganun lang po siya. And next naman is the partition method code. So, ito po yung code for partition method. So, ito po yung syntax of the code of the quicksort algorithm. So, partition of A is, yung A po is element po natin, or yes, and lower bound and upper bound. So pivot is equal to A and lower bound. So start at the lower bound, start is equal to lower bound and end at the upper bound. So ang condition mo natin is while start is lesser than the end, then while A is start, then lesser than or equal to pivot, then start plus plus. Then next is while while A and end is greater than the pivot, then end minus minus. Then if start is lesser than the end, swap A to the start and A to the end. And next is swap A to the lower bound and A to the end, then return to the end. And sa quicksort naman po, quicksort code is quicksort and the value of A, then lower bound, upper bound. So if lower bound is lesser than upper bound, then location is equal to partition of A, lower bound, and upper bound, then quicksort A, lower bound, and location minus 1. Then quicksort A is location plus 1, then upper bound. So, ito naman po yung pseudocode natin for recursive quicksort function. So, lower bound is start index, then high ending index. So, quicksort, then array of lower and higher, array and lower and higher value. So, if low is lesser than high, then P is the partition index, so array P is now at the right place. Then P is equal to partition, then array and low high, then quicksort array low and phi minus 1. So before phi yung ay minus 1, then quicksort array and phi plus 1 is high. So yung plus 1 naman po is after the partition. So meron pa tayo ditong sample code para so ito po yung code natin, and yung problem po kanina is in-input lang po natin dito sa may array natin. So our problem is 4, 2, 6, 5, 3, and 9. So ito po yung naka-randomize kanina. Then after we run the program, ito na po yung nakaayos na value ng mga array natin. So 2, 3, 4, 5, 6. So ito po yung body of code natin. Then this was the output of the code. So next naman po is quicksort time complexity. So in best case, this occurs when partition element has happened to be always the middle element of the array. In such case, following is a recurrence expression. So t of n is equal to 2t and n square and n over 2 plus theta of n. Then thus time complexity for the above expression is theta n log n. Then sa worst case naman po is this case is said to occur in the partition element is always with the smallest or greatest array element. In such case, following the recurrence, so t of n is equal to t of 0 plus t of n minus 1, so and plus theta of n, which equivalent to t of n equal to t of n minus 1 plus theta of n. Thus, complexity in such a case is said to be theta of n squared. And next is the average case. So, such as case occurs when the partition occurs when partitioning divides the elements such as O of n is n over 9, then element are in one set, and 9 n over 10 in other recurrence is such a case. So t of n is equal to t of n over 9 plus 9 over n 9n over 10 plus theta of n. So time complexity is found to be theta of n log n. This above algorithm needs some optimization to reduce the complexity, such as taking a pivot to any random element or reciting the smaller array first and using the tail recurrence approach. Recursion requires a lot of space in function call stack to store the left and right element along with other parameters, such as drawback can be avoided using the below iterative approach to the quicksort. Uh, so yun lang po yung report ko about quicksort, and thank you for listening, sir, and God bless.